The NEET 2019 question. The question is from the topic friction. The problem is like this. A body of mass m is kept on a rough horizontal surface. Horizontal force is applied on the body, but it doesn't move. The resultant of normal reaction and the frictional force acting on that is given by. Let us try to visualize what he is saying in the problem. There is a horizontal surface. On this horizontal surface, there is a body of mass m is kept. A horizontal force is applied on the body. Whenever a force is applied, frictional force develops opposite to relative motion. As the applied force tends to move it forward, that is towards the right, frictional force acts towards the left. What are the other forces acting on that? Its weight mg is acting in downward direction. It's the force applied by the block on the floor. The floor applies a reaction, which is called as normal reaction. So it's very clear in this case that normal reaction equal to mg itself in magnitude. Frictional force equal to mu into normal reaction, that is mu into mg. Now he is asking resultant of frictional force and normal reaction. It's very clear that normal reaction and frictional force are perpendicular to each other. So the resultant will be of that two forces will be, that's what we are trying to calculate is F minimum, so that body moves, right? So resultant of that two will be root of normal reaction square plus frictional force square. Normal reaction is mg, frictional force is mu mg whole square. So when you simplify this, m square g square plus mu square m square g square. M square g square is common, 1 plus mu square. Square root of m square g square will be mg. Remaining is root of 1 plus mu square. That's the resultant force to move the body. Now what we want is the body doesn't move, right? So what we can say? For the body not to move, the resultant force has to be less than or equal to mg of root of 1 plus mu square. So this is the answer for the problem. So in solving this problem, there is nothing special that we need to observe. The only thing is, uh, there is frictional force. We need to know the direction of the frictional force, normal reaction, and we need to observe that they are perpendicular to each other, right? This is how we solve the problem, right? In fact, the direction of that resultant force, if you draw, it will be somewhere here. That resultant force makes some angle with the normal reaction. That's called actually angle of friction, though not required in this problem. So I can write that angle of friction, though it's not required, I'm just doing it, right? Angle of friction can be written like opposite force, frictional force by adjacent force is normal reaction. Frictional force is mu mg, normal reaction is mg. So that's equal to mu itself, right? So what we have done is angle of the friction, I have written opposite force by adjacent force, that is equal to tan theta. So tan theta equal to mu, theta equal to tan inverse of mu, which is also called as angle of friction. Just to tell you what is the meaning of angle of friction, so that it will be useful somewhere else in the other place itself, right? That's it. Thank you for watching. It has to be less than that so that it won't move. If it is more than that, the body will move. Now he said body shall not move, so that we have to have a force that's less than. He has also given an option of less than or equal to, so we have no choice other than taking that option. That's the answer for the problem. Thank you for watching.